Good morning, everyone. It's been about 48 hours since we did our last electroporation test with real fungi DNA. And, well, we didn't get any transformants. Let's take a quick look at these plates. If you look, there's really no colonies growing on any of these tests, which gave us good readings when we did the electroporation. And if we look at our control, however, we'll see that we did get some growth in all three sectors. So we know that the electroporation process did not kill our cells, but for some reason they did not take up our DNA. And so I talked a little bit about some of the things that could go wrong. And if you recall, I used this plasmid that's marked June 8th. And I've actually prepared several batches of the Spanish plasmid since then. And this is one of the areas that kind of makes me a little bit nervous because I don't have a lot of tools at my disposal to validate that this has a good quantity or how much quantity DNA in that. And that's important because that dictates how much DNA we mix into each of our electroporation attempts. But I do have another tool that we can use, and that is running a gel using gel electrophoresis, which I have a rig for right here. Because DNA is negatively charged, we can actually put it on a semi-permeable gel, and the DNA will migrate from the negative to the positive end of the terminal inside of the gel. And with that, we can determine, one, does it have DNA? We can just make sure that when we filtered out the Spanish plasmid from the E. coli, that we actually got some plasmid. We'll be able to approximate the size and approximate the amount of it as well. So I think what we'll do today, in addition to running some additional experiments, I'll show you how to run or set up this gel. And I'm going to run it for each of the different batches of the plasmid because I really do need to know which of these plasmid batches that I created are going to be the most viable, because this is a problem that I definitely don't want to run into when we get into the agrobacteria. So let me get this set up and then I'll show you how to run that gel. All right, here's the plan for creating the gel and everything that you're going to need to create a gel for electrophoresis. You're going to need buffer, and I have this 10x TBE buffer. Now, most of the time, this buffer, I'm not using it, and it sits. And what happens is the borate falls out of solution and accumulates at the bottom. So right now, this is really hot because I just pulled it out of the microwave for about 5 minutes to heat it up enough to remelt the borate into solution. So definitely make sure that you do that because that has bitten me on more than one occasion. So what we're going to do is I have a electrophoresis gel casting tray, and we need to create the agarose gels that are going to go in the casting trays with the combs that we can then move to the rig. And to do that, we're going to create a 1% gel by mixing 20 milliliters of the TBE 1x TBE buffer with some water in this small flask, and then weighing out about 0.15 grams of the agarose. You might be, if you're quick to do the math, you might know that 1.15 or 16 grams is not quite 1% of the 20 milliliters that we'll be using for the gel. And that is because when we go to microwave this to melt the agarose, the water volume will actually drop a little bit and we'll bring it closer to the 1%. Once we've cast the gel, we're going to be adding in this DNA gel stain, and we'll add 3 microliters of the gel stain into the agarose melted gel before it has hardened, mixed it really well. And then we'll pour it into the casting trays and let these set up for 10-15 minutes. And then when that's done, we can move on to taking the gels out, putting them into the rig here, and putting the DNA in there, the plasmids, and then hopefully we'll get some learnings about which of my mini preps are good and which ones maybe don't contain enough DNA in them. And then, yeah, so I'll go ahead and get the camera set up and show you how I cast the gel. guys, while we wait for that gel to solidify, I thought I'd kind of go over what the plan is here and how we're going to do this. Okay, so basically I have 3 plasmid mini prep samples. And if you don't know what a mini prep is, well, it's this kit right here. It's called a molecular biology kit. But what it allows you to do is take maybe some bacteria which has already been transformed with your plasmid, grow it out, and then filter that plasmid out. And the final result of that is your plasmid is suspended in some buffer, kind of like here. And so when I ran my last electroporation tests and I didn't get any transformants, it made me think that maybe there was something up with the plasmid prep. Maybe I did something wrong. Maybe, the cells need to be harvested at just the right time. But I know that I prepared multiple batches and I actually did some quite a bit more recently. So this one was prepared in June 8th, you can see there. But I also have these 2 that were prepared more recently in August, 8/12. These both were prepared the same day. So what I've done is I've labeled both of these A and B since they are the same day. So what we want to test, what we really want to know here is, do these have DNA in them? Number 1, because if they don't have DNA in them, then our electroporation tests are not going to work. And 2, can we estimate what the quantity of DNA is in there? Because the protocols call for specific amounts, and I'm sort of blindly putting 1 microliter into each electroporation attempt, but that's me not knowing what the concentration of DNA in there is. So we can run a gel to sort of figure out what that is. And the way that we're going to do that is by comparing the bands that we get of DNA from our plasmid and comparing that with the ladder. Now here's the ladder that I'm going to use. And so on the left hand side, you can see how the ladder has been designed with specific sizes of DNA, so that okay, there's going to be this top band that's pretty bright. We know that that's 1,000 base pairs, and so if we see one of our plasmids have a band at the same area or the same distance, then we know that that's a 1,000 base pair size piece of DNA. However, in our case, we're using a DNA plasmid, which is a circular piece of DNA, and it's about 9,000 base pairs. So I would expect that I don't have a ladder big enough. They do have bigger ladders that go up to 10,000. But in this particular case, what's going to happen is the ladder is going to continue to go down the gel, but our plasmid is going to be stuck way at the top because it's a lot bigger. Although there are some cases where we might see some bands lower because of something called supercoiling or coiling, where some of that DNA can get really wound up and coiled, and we might see multiple bands. That's okay. There's still something to be learned from each of those. So the gel that we're casting now is going to give us 9 wells. We won't need to use all of them. We'll actually be using only 5 of them, and this is how I've decided that I'm going to lay out the wells and how I'm going to put the samples in each one of them. In lane 1 and lane 5 on either end, we're going to be putting the ladder here. So we'll expect the gel will have this ladder show up on these 2 lanes. In these middle 3 lanes is where I'm going to be putting the plasmid, mini-prepped plasmid for our tests. And I just put the dates. So we have oldest to newest here. And then the amounts of sample, now I've done this before, and the bands come back pretty light. They're pretty faint, and because the concentration isn't very high for these mini preps. And sometimes you can't see anything at all. So that's just one of the things that we're gonna have to play with. But I have a die here. And this is a loading die, and this is what will keep the DNA seeded down into the well of our gel and prevent it from just dissolving and floating away. So that's a 6x die. That means for every 1 unit of dye, we put 5 units of our sample. So I would like to use 10 microliters of the plasmid DNA. So that means we're going to need to mix in 2 microliters of the dye. So we'll have a total of 12 microliters put into each of these 3 wells here. For the ladder, we only need 5 microliters of the ladder for that to be successful. Here's what the ladder looks like. And yes, we also, you probably saw that when we made the gel, we put in a DNA fluorescent dye. That will make it as well so that the dye fluoresces. And that's kind of why this box, this lid here is orange, because it filters out blue light and allows us to see that the fluorescence coming through. Okay, so let me go ahead and pull out the gel and get that seated in here, and we'll go ahead and get these pipetted or mixed up and pipetted into the gel, and then we'll run it and see what we get. Alright, I got the samples loaded in here, and yeah, things did not go very well with loading it. For whatever reason, I just could not get the loading dye to mix in very well with the plasmid, and as a result, it started to just float out of the well. So a couple of them I had to reload one time, and this second lane into the middle, this one right here, is just loading dye. And then I also mixed up the A and the B, so those are reversed. So this is the oldest plasmid, and then there's B, and then there's A, and then I have the ladders on the ends. So we'll let it run and see how it goes. I can already start to see a little bit of a band underneath the ladders forming. We'll see if, at the very least, hopefully some of these inner wells will show us that we have DNA in them so that we can proceed with our testing. Okay, it's been about 10 minutes. Let's check on our gel and just see if there's anything we can learn so far. Okay, well, we see the ladders on the far left and right side. Get the camera to just do a little bit better job here. There we go. We can see that the ladder is forming on the left and right side, and if we look just to the right of the first ladder, there's a very, very faint band at the top. The second lane as well. So that's good. That looks like that's the start of our DNA, or at least that confirms that the two older mini-prep samples have DNA in them. So I'm going to continue to let this run a little bit more and see if that last lane before the ladder on the right-hand side, also has DNA. So let's let this run for maybe 20 more minutes and we'll see what it looks like. All right, we're 20 minutes in, so let's do a little check and see what we see. So our ladders are pumping along nicely, and we can see in that first lane to the right of the ladder and the second lane, there's clearly some faint bands up there. So we know that those have plasmids. So you can almost see a double line, which is kind of common with the coiled plasmid. And then I think just below some of the bubbles on the far right lane to the left of the ladder, I see a faint line there as well. So I do think all three of these look like they have plasmid in them, which is a good sign. The next thing that we need to do is go ahead and continue to let it run. I'll let it run for maybe 10 to 20 more minutes. We'll check on it again just to make sure that there's still some good bands at the top there showing us that we have some DNA, we have plasmid, and yeah, then we'll take it to the next step and go ahead and perform some more electroporation tests. Before we continue, I have to confess something to you guys. When I ran this last test with DNA, I was really, really tired, and I thought I would try to cut some corners. And what I did was in an earlier video, you saw me prepare one of these liquid cultures, and by the time I got ready to prepare a plate with a lawn, that culture was already a few days old. And then when I tried to put it on the lawn, what you didn't see off camera was that after 6 hours, really not a lot had grown. So I put more of the old culture onto that plate, and then I let it grow overnight. And then there was some new growth, but it was really thick and old, and it didn't look like when I ran my first tests. And so when I read these papers, one of the things that they always emphasize, and one of the things they have you do, is prepare fresh cells, because you want to capture the cells when they're in their log phase of growth. And that's probably just a fancy way of saying when in their early stage of growth, when they're new, fresh, and rapidly growing, doubling every hour, I think is a proper definition of it. And so by the time I ran the experiments with DNA, I was actually using some fairly old cultures, old cells, and there was probably a lot of dead cells in there as well. I'm not sure how that impacted it. But yeah, because I tried to cut some corners and tried to save on time, cost, materials, and effort, I think that's also probably a contributor to why I got 0 transformants here. And part of that is I've just been running myself ragged trying to do all of this, and filming it makes it considerably more difficult because you have to like hold the camera in a certain way, and sometimes it gets complicated and there's just a lot of work. And so I wanted to be honest about that, but also there's a learning behind that too. And so use fresh cells, that's really important. So what I did was last night I seeded this, and you can already see how much it's grown. And then there's a fresh plate in there. We're only at about hour 3, so about halfway. Once that's done, then I'll be able to use that fresh lawn for the next round of tests. And yeah, so I just wanted to share that with you. So I decided to retake a look at those plates from the last electroporation run and look at them a little bit more closely. And I noticed something here. Let's see if I can zoom in. Look at all of those colonies there along the edge of the plate. Now that could be 2 things. It could be that these were successfully transformed, and I could test that by putting these on another plate, or taking one of these colonies and putting it in some liquid culture with kanamycin and seeing if it grows. But the question is, why are there all of these colonies on the edge? And I have 2 theories about this. You see, this table, it sinks in the middle. And you can't really tell from here, but because my flow hood is so heavy, it makes this surface completely uneven, so that whenever I try to do any kind of spreading or plate work that requires it to be evenly spread, it inevitably kind of leans to one side. And you guys have seen why I transfer the plates over onto the table like those right there, because that is an even surface. So it could be that when I put kanamycin on this plate, I just didn't reach to this far outer edge. And so the bacteria that lived for the electroporation experiments just started to grow over here. It could also be the same thing, but the kanamycin worked, but when I spread the recovered electroporated cells, they ended up all kind of floating over to the side here. And so I'm looking at, like the innermost colony there, and that's pretty close. It would be really hard for me to believe that kanamycin, as much as I put on here, didn't spread to that particular area. But that's something to keep in mind. And if you don't look at these plates closely, you might have missed that, or I might have missed that. But it's not the first time that it happened. It can be kind of difficult for me when I'm working in this less than perfect setting to watch out for things like these. But I wanted to share that with you guys.